uniform circular motion. Circular. Let's see all the basic concepts first. That's number one. Tangential speed. Tangential speed is constant. And second important thing, tangential velocity is not constant. So what does it imply? When you look at these two statements, you can see that the body keeps changing the direction of motion. Body keeps changing the direction of motion. So we'll have a bit of a recap on this. How does it happen? Let's take a simple case here. Not uniform circular motion. How do you make this happen while the velocity remains changing but speed remains constant? Take a look at here. Suppose we assume that this body is moving at the beginning in this direction. Okay, let's put an arrow in here, show the direction. Now, you don't want to change the velocity of this body, but you don't want to change the speed of this body, but you want to change the direction of motion. What would you do? If you want that to happen, you have to apply a force perpendicular to the direction of motion, like this. If you apply a force perpendicular to the direction of motion here, it will change its trajectory a little bit to this direction. Now again you apply a force in the same direction, maybe a constant force F. Again it will tilt further. And again you can apply another force. So what will happen? It keeps changing the direction all the time. You can see that. You keep doing this continuously. What would be the outcome? Keep applying forces perpendicular to the direction of motion all the time. So what happens? It follows a circular path provided the magnitude of the force C. So this implies, these two statements, the statement 1 and statement 2, imply that to keep a body moving along a circular path, you need to keep applying a force perpendicular to the motion at every instant. Let's assume that the body is here at one instant, and at a later time, let us assume that this is, it doesn't look nice, and let's do it again. Let's assume that it's here at a later time. So look at what happens in here. We know that the tangential speed remains constant all the time, but keeps changing. The direction of motion keeps changing. Now let's see that at this point, this is the tangential speed. Okay, let's put it here an arrow, so that gives you the tangential velocity. This is the tangential velocity here. Both the tangential velocities will have the same magnitude, though they are different vectors because they are in different directions. So we can say this is V1 and put an arrow here to make sure that this is a vector. This is V2. So what does it mean now? If this has to happen, we need to apply a force perpendicular to the motion at every instant. Here, you need to apply a force in this direction. Here, you need to apply a force in this direction. Same force in magnitude. So, it should be a force with the same magnitude. Here, you need to apply a force in this direction. And here, you have to apply a force of same magnitude in this direction. Here, you need to apply a force in the same direction, and same magnitude. Always perpendicular to the path. So I'll put arrows in here to show that these are the conditions essential to keep the body moving in a circular path. Let's mark it as F so you won't get confused. So this force is essential to keep the body moving in circular path. This is usually called FCP, centripetal force. So the idea is pretty simple. Let's write that idea as point number 4. To keep the body moving in a circular path at constant speed. That's an essential condition because that's what we are working on. At constant speed, this is only this particular case. A force of magnitude, a force of constant magnitude need to be applied, we can write instead of applied, we will write need to be provided with, need to be, I think it looks, need to be provided with perpendicular to the machine. Perpendicular to the motion. This idea is very important when you learn uniform circular motion. To keep a body moving in a circular path, you need a force perpendicular to the motion at every single instant, at every single point. You call this force, this force is called, I think many of you are familiar with that, called centripetal force. Centripetal force. And obviously this centrifugal force, as you have seen in the example, always acts towards the center. So this acts towards center. Towards the center. Now, this is usually represented by FCP, centrifugal. Now, since there is a constant force acting towards the center, we may write that The body is accelerating. The body keep accelerating, always accelerating, right? Always accelerate towards the center. How does it happen? Simple application of Newton's second law. Towards the center. This acceleration is called centripetal acceleration. This is centripetal acceleration, and it's often represented as ACP. This is just a consequence of Newton's second law. Look at here. F C P is equal to n times A C P. You may use vectors because that will be perfectly fine, because FCP and ACP will be in the same direction, always towards the center. Now this is the general concept of uniform circular motion.